Before I get too far into this, I just want to remind you that there is a PDF version of these problems on Edmodo, so you can print that out and then you don't have to worry about copying all the problems down. And this is serving both as a review for your quiz next class as well as a review for SOL. So starting with finding the inverse. The first step in finding your inverse is you don't want to use any function notation. You want a y instead. So I'm going to go ahead and just go through all three of these and replace this with, oh no, I'm not going to be able to fit that. No! Okay, I'm going to have to do that one in a minute. It doesn't fit on here. Dang it. All right, so let's go ahead through this. Well, remember with inverses, the x and y switches, so we're going to flip-flop the places. There we go. And then we solve it for y by subtracting 2 to get x minus 2 equals y. And then we write our inverse function notation, so f inverse of x equals x minus 2. And so this would be your inverse. Second problem here, we are going to start with flipping x and y, so x comes here, leaving us with 5y cubed minus 9. Add 9 to both sides to get x plus 9 equals 5y cubed. We're going to divide by 5, and leaving with x plus 9 over 5 equals y cubed. And then take the cubed root because that undoes the cube. So cubed root, and that would leave you with the cubed root of x plus 9 over 5 equals y. And remember, you always want to write your inverse notation, so I'm going to write g inverse. That's supposed to be a negative. I guess it kind of didn't really come out that great. -1, there we go, of x equals the cubed root of x plus 9 over 5. And that would be your answer for this one. All right, so now let me go ahead and scroll back up here. There we go. And shift over to number 3 since I was out of room. All right, so number 3, same thing. Start with y instead of your h of x. 2x squared plus 3. Flip your x and y, so x equals 2y squared plus 3. Subtract 3 to get x minus 3 equals 2y squared. Divide by 2. X minus 3 over 2 equals y squared. I'm going to scroll down a little, and then we do our square root on both sides of the equation so that our square and square root undo one another, leaving you with the square root of x minus 3 over 2 equals y, and then flip to your inverse notation. And I believe this one was h inverse of x, was h of x to begin with, and square root of x minus 3 over 2. And there's your inverse. All right, and I apologize now, I'm going to have to shift all of these over because there's 3 problems for each and they're not going to fit on the screen. I'm not going to be able to do all of them on the screen. All right, so simplifying radical expressions. You can do these completely in the calculator, and remember that what you want to do for something like the square root of 12 is that you want to go to y equals, you want to type in 12 divided by x squared. And that's because you're doing square root. Where over here, you would do 16, so y equals 16 divided by x cubed. And then you go into the table, which is second graph. Okay, so just a reminder that that's how you get to that from your calculator. So when you're working with these problems, you can only, so wait a minute, why is this so large all of a sudden? Lord, you can only add or subtract when they have matching square roots, but you need to simplify first. So when you start with simplifying the square root of 12, remember again, you can use the calculator and look in the table. And remember that you're looking for 2 whole numbers, 1 in each column. The one in the x column comes outside of the radical, and the one underneath, or 1 in the y column, stays underneath. So this 2 is going to carry down, but the square root of 12 becomes 2 times the square root of 3. And then we have plus 3 times the square root of 3, which cannot be simplified. Well, out here we can multiply those 2 together to get 4 times the square root of 3, and we can add to that 3 times the square root of 3. And from here, because their square roots match, we get 4 plus 3, which is 7, times the square root of 3. So remember that it's just like doing 4x plus 3x, and that's 7x. You don't change the x at all, so just like the square root, we don't change it, we keep it as a 3. All right, now when we go into our next problem here, we have the square root of 72x cubed. So we start with simplifying the square root of 72, which ends up coming all the way down to, whoops, so I'm going to split this into square root of 72 and the square root of x cubed first. So square root of 72 comes out to 6 times the square root of 2. X cubed is not divisible by 2. Remember your little index of 2 here? So what we're going to do is split it into x squared times the square root of x. So this, we take our exponent of 2 and divide it by our index of 2, which leaves us with x. So x comes out, and the 6 is out already. Square root of 2, we have the square root of x. So this whole first expression is now 6x times the square root of 2x. And with that, we are going to subtract, and now over here, I'm going to split this into the square root of 25 times the square root of x cubed. The square root of 25 is 5, so that comes out to a perfect square. All right, so 5 is out, and then this is exactly the same as the last one. We split this up into x squared and x, and the x comes out because you take your exponent and divide it by your index, and then we have this underneath still. So in this problem right here, we get 5x times the square root of x. All right, now as you're looking at these, our square roots do not match. This one is 2x and this one is x, and so this is your answer. You're done. You cannot go any further than that right there. Okay, and then moving on to our next one, and again, I'm sorry, I have to keep shifting. This is super annoying. So now we start with simplifying our cubed root of 16. So I am going to, actually I'm going to go ahead and erase this to get it out of the way for right now. All right, so cubed root of 16 and times the cubed root of y to the 9th. So using your calculator, you can do cubed root, or I'm sorry, not cubed root, but do 16 divided by x to the 3rd and go into your table, which gives you 2 times the cubed root of 2. And then y to the 9th, 9 is divisible by 3, so it becomes y cubed. So this whole first term here becomes 2y cubed times the cubed root of 2. And don't forget your little index of 3 there. All right, your next one. We're adding to that. We have the 3, which we're going to leave, and then we have the cubed root of 54, and then also the cubed root of y to the 9th. So we've got our 3, which stays, and the cubed root of 54, which 54 isn't a perfect cube, but it does simplify down to 3 times the cubed root of 2, and we already know that this becomes y cubed. So we're going to multiply the 3, and the y cubed, so we have plus 9y cubed, and then under the cubed root we still have a 2. So this was out, this was out, this was not, that one comes out. All right, and then we have minus 2, and I'm probably gonna have to shift this over again. Dang it, dang it. And the cubed root of 81, and this one is actually a perfect cube, but again, you can use your table. And so, wait, is it a perfect cube? No, it's not. Hang on. Have I lost my mind, people? I lost my mind. It's not a perfect cube. Goodness gracious, what is happening here? All right, so this becomes 2, or that stays as a 2. I shouldn't even recopy that. And then in the calculator, I have here that this becomes 3 times the cubed root of 3. All right, so we get minus, we have 2, and then this, the 2 and the 3 are outside, multiply them, cubed root of 3. Okay, now looking at your answers here, look at your cubed root of 2, cubed root of 2. It has a y cubed and a y cubed, so we can add those together. 11y cubed times the cubed root of 2 minus 6 times the cubed root of 3, and that is your answer. Phew, all right. Writing in radical form, remember that it is exponent over index, and you have to have your denominators the same. So I'm going to start with the fact that this is 2 over 1. Their common denominator would be 4, so I'm going to take the 2 over 1 and change it to have a denominator of 4. I'm going to take the 1/2 and change it to have a denominator of 4, and then the 3/4 is good to go. So we get 3 to the 8/4, and A to the 2/4, and then B to the 3/4. And now that they all have the same index, you can write one big 4th root because of the 4, 3 to the 8th, A squared, B to the 3rd. And you don't really need to do 3 to the 8th. You can leave it like that. All right, this is actually a -5/6, so if it's kind of hard to see on the paper, I'm really sorry. All right, so if it's negative, we need to move it to the denominator to make it become a +5/6, and then when we put our radical, 6 is the index and 2 is the exponent. And that would be your answer. Okay, and then with number 9, sorry, I have to shift it. Oops. So number 9 here, again, get a common denominator, which in this case would be 24. 4, 8, and 6 all go into 24, so we'll take 3/4 and multiply it by 6/6, take 1/8 and multiply it by 3/3, and then take 5/6 and multiply that by 4/4, leaving us with 4 to the 18/24 times x to the 3/24 times y to the 20/24. So your index is going to be 24, and you will have 4 to the 18th, x to the 3rd, y to the 20th as your final answer. All right, now in this one we're going backwards. So anything that doesn't have an exponent written has an exponent of 1. So all of those have a 1. So you take 12 and raise it to the exponent over index, x to the exponent over index, and y to the exponent over index. And from here, the only thing that you do as an extra step is simplify this one down to 5/2. And that would be your final answer. So number 11, 10 gets raised to the 1/3. X gets raised to the 6/3, and y gets raised to the 12/3. But again, simplify every fraction that you possibly can, which makes it x squared, y to the 4th. Okay, and then your very last example for this one. So taking, whoa, hang on, sorry. Okay, so taking 8, and remember your index is 2, so this is 8 to the 1/2, x to the 5/2, y to the 10/2, and simplify anything that you can, which in this case would be only y to the 5th. And there's your answer. All right. Logarithmic form. So remember, we do our fish hook. We start here, we work to the other side of the equal sign and back to the 7. So it becomes log base 2, 128 equals 7. Start at the 7, work your way to the other side, come back to the -2. So we start at the 7, work our way over to the 1/49, and then end at -2. And then this one, same thing, and I have to shift it. Oh my god, this is so obnoxious. Ugh. All right, and so we start at our base, work our way around, loop back. So log 64 goes down here. We went around to 16, and we ended at 2/3. All right, so this one doing the same thing, except we're going to exponential. So 15 around to the 2, end at 225. So 15 squared equals 225. Fish hook, 3 around to -3, end at 1/27. So 3 to the -3rd equals 1/27. And then your last one here, starting at your 4 and working your way around to the 5/2 and ending at 32. So 4 to the 5/2 equals 32. Okay, now these ones, whew. All right, I am not going to get through these ones. So how about we can do these in class together. Okay, that way you can make sure you're really totally ready for this quiz, but it's just solving them like regular equations.